Hi everyone. I hope you're enjoying the inaugural Inforce conference. Everyone hears me okay? All right. My name is Iran and I'm a security consultant and a developer on the AWS Jam platform. That's the platform that runs the Capture the Flag, the Security Jam, and the Jam Lounge in this event, in other events. By a show of hands, any of you played with us with those events at this conference? That's very nice. That's great. I encourage you. We still have another Security Jam at 12:30. So with everything we build at AWS and at Amazon, we start with the customer and move backwards. And to help customers learn more about AWS, AWS security and AWS in general in a fun way, for reInvent 2016, we created the Security Jam. It's a gamified platform where you can solve challenges and learn hands-on. So as it grew, and we got good feedback, it grew to be a bigger, to have more events and more things happening in parallel. We had to build a tool that will manage it in the backend, and we wanted it to be serverless. We wanted it to be using our own corporate permissions and groups in order to handle access control, who can create events, who can create challenges, who can launch events. We wanted to make sure there's a 4i review to all that. And in this talk, we're going to talk about some of the best practices and tips we learned as both AWS employees, but also AWS customers ourselves, using Amazon Cognito and AWS Lambda. So we will, I'm not sure if all of you are familiar with Amazon Cognito. By show of hands, who is familiar with it? And okay, so that's a lot of hands. So I can probably skip, get that part out of the way relatively quickly. We'll show a demo of a very simple application that handles access control based on an external IDP. And we will go over the architecture overview, and then in the end, we'll deep dive into the code. And I know that's probably what's holding between you and lunch, so I'll try to make that interesting and succinct. But for those of you who are not developers, I still encourage you to stay for that part, because it will help tie everything in. So imagine the following conversation. Anyone heard that kind of exchange? Probably not, right? But so even though that's probably not a realistic feature for an app to just have the ability to do single sign-on, how many of you had the case where you had to develop an application that needed authentication and authorization? Pretty much a common requirement. But identity is heavy lifting, right? You need to do all of those things to make it right. It's not always easy, right? To store passwords securely, hash them, salt them, and all that. It's an art. It's heavy lifting. It's transparent to the users. You only know if you did it wrong if something bad happens. In addition to that, now users expect to be able to log in through social providers and through external IDPs, and you need to handle all that as well. So Amazon Cognito comes into the picture. Your developers can focus on what differentiates your app, focus on the business needs, and let Amazon Cognito handle identity. Amazon Cognito consists of user pools, which is a managed user directory, hosted UI. It handles standard tokens, and it can handle social and external IDP federation. And we also have Amazon Cognito identity pools that can allow application users to get AWS IAM credentials to do things directly with AWS services. For example, the classic example is uploading an image to S3 directly from your application without the need to go through a backend. Some of the key features quickly of Amazon Cognito user pools. It's a serverless directory. You don't need to manage servers. It's API driven. Everything is, every access to Amazon Cognito is through IAM, right? and it's multi-AZ. It has another feature that is called groups, and it's going to be important for our demo. The special thing about groups is that not only you can arrange your users within groups when Cognito is the source of truth, but it's also possible, we'll show in this example, to map an external group from your external IDP, for example, an LDAP group, an AD group, or other attributes, into what we have here in Cognito, a Cognito group. And another benefit of the group claim is that the group claim will be both in the ID token and the access token. So this is helpful in case you want to work with access tokens and not ID tokens when you make API calls. Another cool feature that we liked is the hosted user interface. You can build, if you want to allow both several external IDPs and also username and password, you can have a custom UI that you don't have to build yourself. In the first iteration of the Jam platform, we built the customer-facing part was built. We built the our own UI, and there's a lot of work to do that to do it right. Forget password, verify email, and all that. This is all handled for you in the hosted UI. Support for OAuth 2 flows. And we'll focus on the authorization code flow, which may surprise some. There's a recent internet draft that is recommending to use the authorization code flow even for browser-based apps. And it recommends using a feature called PKCE or PIXE. And in our demo, we have that enabled through a product called AWS Amplify. Anyone here heard of AWS Amplify, used it before? Okay, well. So the way federation works, you have multiple identity providers. All of them will become a unified user profile. So your application developer doesn't need to worry about where the user came from, where the claims came from. It's all mapped to a unified set of standard attributes. And you can have the option of adding custom attributes as well. The application receives standard OIDC tokens, an access token, an ID token, and a refresh token optionally. And the way this works with federation, users are being redirected. If you know the IDP in advance, you can skip that page completely. You can go directly to step number 3. Go directly to the IDP. It's going to be a seamless redirect for the user. They're going to land on the IDP. Now, if your IDP is, or the user is already signed in to the domain, they logged into the laptop, they will immediately redirect back with a SAML response, and then Cognito will map the SAML response to the profile. And then you're going to have a chance, there's a trigger that we're going to show that allows you to modify how this mapping happens. If it's not just a one-to-one mapping, attribute to attribute, if you want to do some more logic around it, you can use a Lambda that we'll show later to make that more customized. And then the application receives the tokens, and every API call is going to use those either ID token or access token for making API calls. And in the application, the claims of the token can be used to make decisions about authorization. Another thing we liked about working with Amazon Cognito is that it has built-in integration with a lot of other services. For example, Amazon API Gateway, and also recently the AWS Application Load Balancer. It's a great integration for different types of apps. I would say for API Gateway, if you have a fully 100% single-page application, everything is just JavaScript and HTML and static assets sitting on S3, then this is a classic pattern for using Cognito with API Gateway. If you have a more classic app where you're using a cookie to preserve a session, but you still want your application to work with OIDC tokens, then the application load balancer is a great solution for that as well. We will focus in this talk more about the API Gateway integration. There are other services that integrate with Cognito as well, and more are coming every time. All right, so without further ado, I'm going to do a quick demo of what we're going to Okay, so to demonstrate that, I built a very, very basic application that is using single sign-on to demonstrate what we talked about right now. In this case, I'm going to show two buttons here. One of them is going to show me the hosted UI. Okay, I didn't customize it. This is how it goes out of the box, but I can add logos, change the colors, and all that. In this case, I chose to enable an external IDP. In this case, I'm using Okta. Or users can also log in with username and password. This is for perhaps an application that supports both internal users and also external users, just like we have for the Jam platform. Alternatively, let's say if it's only intended for internal users, I will show you in the code later on, by passing the identity provider name, you can skip that page if it's not relevant to save some clicks for the users, and they can just go directly. So what happens behind the scene? It goes to Cognito, and then immediately redirects to the IDP. In this case, we're going to log in. As Bob. All right, and again, sorry for it's not a VR meeting room application. That's going to be probably the next iteration. But just to demonstrate, this is an application user that came from Okta. And just for demonstration purposes, I'm displaying here their, maybe I'll make it a little bit bigger. I'm displaying their Okta group. Okay, they're a general user of the pet store. And the authorization logic behind that user is that they can only see pets that they own. Okay, if they try to create a pet with a different owner, they'll fail. And now we'll go to, in this case, I already logged in a different session with a user named Alice. And she has two LDAP groups or Okta groups associated with her user. And she's an admin. Therefore, she can see all the other users' items. So this is not just general access control, it's also more of a row-level security based on their external IDP credential, the external IDP entitlements. And I just enabled other features such as you can update, and I can also update all right. So all right, so we're going to move on to talking about the architecture of all this real quick. All right. So what we're building, how did we build this? And before I want to deep dive into that, I want to talk about the concept of where do you want to handle access control on the application level. So there are several ways to do that. One of them is policy-based. You can use, for example, IAM policies can control API gateway access patterns. You can decide that this user role will only do a get on this path pattern, and a more powerful user will have post, put, and delete on a larger, a more general, it will have more stars in it, pattern. Okay, so you can do that as well. This is great, in my opinion, for API to API access. The benefits of it, it's centralized, it's declarative, it's role-based. Another way to do that is interceptor-based. For example, API Gateway has a feature called Lambda Custom Authorizers. Before any request is getting in, the Lambda will be triggered, we'll look at the request, we'll decide, we'll generate a policy on the fly that will decide whether to allow that or not. And this is great if you want to have a coarse-grained, external, layered security level of protection before any request is coming in. Now, both of those have been discussed, and there are a lot of examples and a lot of talks that discuss those two options. Both of them are part of the options when you choose how to authorize API gateway calls. And I want to talk about the third one, which is a layered security approach where the authorization logic is going to be in your application code. And the two benefits, in my opinion, in here are you can have access to domain objects that are not always accessible to an external authorization layer. And even if you were able to make them available, it's not always making sense in terms of data borderlines between layers. You don't always want to expose your internal data to an external authorization layer. So this is, again, this is defense in depth. There's no one option that is the best. Usually it's a combination of several options. We're going to focus on the last one. Another great feature that I found very useful is that when I do this, I'm able to test authorization logic offline, regardless of where is it running. It can run on my laptop. It's decoupled from anything else. And I can make sure that the authorization logic is sound. So then we're going to show a little bit of how those unit tests look like. And again, the concept of authorization being a little bit of business logic is not something I made up. It's just one approach. So how everything is tied together? And we'll go over the code and we'll go over the console. Again, the purpose is not to bore you with 1,000 slides, but this is the main technique that we used. Outside of the scope of our application, in the IDP, we map LDAP groups to SAML attributes. In Okta, I'm doing it by assigning everything that starts with a pet app will be mapped to those SAML attributes. I don't want to send all of the LDAP groups that the user is part of to my application, so I take a very small subset that is interesting for my app. Okay, so that's done in Okta. I can show you how it's done there. It can be similarly done with other IDPs. Then the SAML attribute is being mapped into a just-in-time user profile within Amazon Cognito. It will either be created or updated when you do this federation. This user profile, using a Lambda trigger that we'll show later, you can map those attributes into groups and optionally even to roles. This will go into a JWT token, a set of 3 tokens, the ID, the access, and the refresh tokens. And then it will go to the app. AWS Amplify will use that to make calls to API Gateway. API Gateway will automatically validate those tokens that the signature is correct, that were not tampered with. The user didn't add some claims to it that they're not supposed to. This will go to our backend app, and in our backend app, we'll show how we take those roles, those groups claims, and make a decision whether to allow or deny. In a more of a flow, we have AWS Amplify that is used to save you the work needed to handle all those redirects, to redirect, to log out, to log in, to capture the authorization code when it comes in, to hide it from the URL so it's not staying there when you bookmark, and things like that, all with a few lines of code. Then the IDP will authenticate and send the SAML response that we showed before. Cognito will handle the SAML response for you, so you don't have to do that. It will map the user attributes. The Lambda hook will do this assignment. The signed tokens are going to be returned. Amplify will store those tokens and will handle refreshes as well. So you don't have to keep refreshing those tokens by yourselves. It's going to be done for you. The client app can make a call to a protected API, and you're going to pass the token as part of the authorization header. And then Amazon API Gateway, using the user pool authorizer that we'll show later, it will validate the JWT token for you to make sure that it hasn't been changed and didn't expire, and we'll pass it to the Lambda, including the token claims. The application code will read it, read the group's claims, and make a decision. So it sounds perhaps, excuse me, it sounds simple perhaps, but it took us a while to get into that pattern. I'll go into a little bit of a deeper dive on the code and a little bit on the console to show you the architecture through the console. By the way, the code is going to be available on GitHub, and there's going to be a link at the end of the presentation. All right. So the first thing I want to show is this is, for example, the implementation of the path to get all pets. Okay, this is an Express.js code. For those of you who are not familiar with Express.js or with TypeScript, this is TypeScript. It's a superset of JavaScript that offers static typing, and everything in this repo is going to use TypeScript. And in this case, we see the implementation of the backend code that handles the get all pets request. And what happens is that I added through a middleware an attribute called groups. It's a set. All you need to do is to check if the user has this claim. If they have this claim, we're going to give them all the pets. They're admins. Otherwise, we're going to give them pets by owner. So this is a little bit of a row-level security implementation. And you'll see, if you look at the repo, you'll see other methods implemented in a similar way. And all of this is happening thanks to a very simple middleware that I'll show later, because it's a little bit going to be a little deeper dive. But I'll show it later, and I can go over how it's working. And this is what injects that request inside. All right. Now we'll skip a little bit to the front end. So I'm usually writing in Angular, and I decided for some reason to try it in React. So if you look at this, and it's not idiomatic React code, so it's my apology, and you're more than free to open issues and send pull requests to make it better. So I apologize if it's for those of you who are React developers for butchering React for this demo. And we'll look at the main component. In this case, so this is how I'm making a request. I'm going to ask from, this is Amplify. The auth object is from Amplify. I'm getting the current session. And I'm passing the current access token as part of the request. This can be done in a nicer way, probably when you use Angular or other, or in React when you use other interceptors. This is just to make a very explicit example of how it can be done. All you need to do is pass the authorization header to when you make a request. Then let's say you have a UI and you want to hide certain things that the user doesn't have access to. For example, an admin tab or something like that. It's not enforcing authorization, but you want to make an optimistic UI. You want to make sure that users don't see things that they cannot use. So just like you could get those claims in the back end, you can also get them in the front end. And to do that, I created a little helper class called user. It will get the Cognito user from Amplify. So you don't need to generate the Cognito user object. It's going to be provided to you from Amplify. I'll show you later. And to get the information about which groups the user is part of, that's all you need. You basically have all that as part of the user session. And all of this is has all right, we'll show the unit test in a minute. All right, and then how do I use that? I can use that to display those groups. In this case, I'm just displaying them on the screen. In addition, I can show the username. In my case, I want to show the first name. I don't want to show the full email. So all I do is user.claims, getClaims.name. So the same claims both in the back end and the front end. And I want to see if there's anything else I want to show in the front end. Yes, so this is using, as I said, it's using Amplify. So in order to enable all this complex flow of getting back authorization code, storing it, making a call to get the tokens from the authorization code, it's handled for you. All you need to do is listen to an event from the Amplify hub. If the user is signed in, this is how we get the user. I just pass it in. If there's a failure, I make sure that I clean up the user state. And this is for listening for events. And when the page loads, I get the Cognito user from this method call. That's basically all the code I needed to add to the front end to make this all work together. Okay, and now to the secret sauce. So we want to go into so this is the Lambda that is making this mapping happen, okay? So this is a little bit, may need some explanation, but in general, there's a documented page in our documentation that shows what is the request format and what is the output, the response format for this Lambda. And all you need to do is to return the structure. Okay, and this is why I provided it already created in an example, so you don't have to worry about that. But a little bit about what it's doing. So it will take an existing user attribute, a custom user attribute, and then will parse it so that it's instead of a list of comma delimited group names, this is how it usually comes back in the SAML response. You have square brackets and then the group names. It will parse it and make it into an array in the token. That's basically all this code is doing. It's taking a list of strings, splitting it, and putting it in an array. And then it's hiding that attribute we used to make all that, the mapped attribute. It's going to just hide it. We don't need to have both the groups as an array and as a custom attribute. So we're suppressing that attribute name, okay? And that's about it. That's about the pre-token generation Lambda. And we'll revisit it when we go through the console to show how that was built. And this is basically the main components of the application. And so the question can be, how is all that built? Do we go and create it in the console? Do we need to run a CloudFormation stack? And the answer is neither. There is a new feature called CDK, which is in developer preview, that allows me to really use code to create infrastructure. It's really infrastructure as code. Not just a YAML file or an XML file, it's actual code. In this case, I'm using TypeScript, so the entire repo is using the same language. And I want to show some interesting, some things that you might find beneficial in that repo that can save you a lot of time. We'll start by creating the user pool. So in CDK, there are two types of constructs. There is a low-level CloudFormation construct that is very similar to the way you would see it in CloudFormation. Same attributes, same structure, more or less replicating what you have in CloudFormation, only in a different language, either in JavaScript, TypeScript, in Java and other languages. In this case, I'm creating a user pool, and there's nothing special about that construct. I'm also creating two tables. In this case, I'm creating the table to hold the pets and also a table for some information about the users. I'm not going to store any personal information there. I want to have that stored in Cognito, but I want to store other things. For example, if the user wanted to do a sign out and sign out of all other devices, I'm storing that timestamp there. And if I get a token that was created before that timestamp, I know that token is no longer relevant, so I just reject it. It's kind of a way to make sure that that token is immediately no longer valid. Then the API function. This is my Lambda function, which is pointing to my other folder where that API function you saw before. I'm passing some environment variables, so I don't have anything hard-coded in that function. And this is interesting. That's another cool feature I really liked, that instead of making sometimes error-prone changes to the IAM policy with CDK, I was just able to let the items table grant access to the Lambda, and it will generate just the right IAM policy for the API function to be able to access that table. And so this is for, as I said, there are two types of items in CDK. One of them is a low-level, everything that starts with CFN. It's exactly like it is in CloudFormation. And there are high-level constructs that build on top of that to make perhaps an easier, higher-level access to those resources. So for those resources, you can have those cool methods like grant write data, grant read data, or grant full access. For if you want to create a little bit more elaborate policy, you can do that as well, using a domain-specific language right here. I'm doing the global sign-out from the backend instead of the front end, so I need to provide permission for that. This is the authorizer. This is the configuration that tells API Gateway to look for that token, for an access token, in the incoming request, and do that automatic validation for us. Okay? So yeah, as you can see here, I'm capturing all the requests. For this example, I'm just capturing all the requests and just passing them to my Lambda and letting that my Lambda to handle that. I'm adding CORS options. That's another cool thing about CDK, where I can use utilities and import other classes that I can reuse. So instead of having very large files, I can just import from my local NPM repository things that other teams have created. In this case, it's going to create a CORS configuration that is locked to my specific domain. So it's recommended to make sure you don't use star for CORS. So that's doing that for me. That's the pre-token generation Lambda. And here I want to show you something interesting that probably can save you a lot of time. There's sometimes things in CloudFormation that are not yet available, that are available in the console. So to handle that, there's a concept called custom resources in CloudFormation. And with CDK, it's very easy to create those custom constructs. And to make life easy, I created custom constructs for any small thing missing in Cognito, in order to make sure that everything is in code. You don't have to do anything in the console. So all those constructs have been created. They are part of the repo. One example is that pre-token generation construct. All I have to do is pass the user pool and the Lambda, and it will make that connection between them. The attribute mapping that we talked about is being defined here. And I'll show later how it looks like in the console after I run this after I deploy it. I map email to email, family name, last name from Okta will go into family name, and so on. And the group, this is the important part, the groups claim will be mapped from the group's attribute from Okta. It will be mapped into a custom attribute in Cognito. This is the IDP settings. All you need to provide is the metadata URL, and all of this basically be set up. And it can support any provider type. In this case, I'm using Okta and a SAML provider. This is the app client settings. So the callback URL and the logout URL is being set here. The scopes that are allowed for that app client, and I'm choosing the authorization code floor in here. I can set up the Cognito domain. So part of the very few configuration that you need to pass for this to work, you need to tell it which prefix you want to use for the domain. And I know that was long, and thank you for your patience, but that's basically the entire infrastructure. And the rest is being output as output variables. And in order to deploy this, so some commands that you may find in the repo that can be useful. One of them is synth. So TSC is basically compiling TypeScript to JavaScript. And this is the CloudFormation that's been generated from all that. I know about you, but I prefer not having to write all that by hand. Even though it's readable and idiomatic, and it can be, you can use that if you have a requirement to only use CloudFormation, you can use that output and then deploy it. Alternatively, another interesting feature before I show how it's deployed is diff, which is another feature I liked. In this case, it won't show a lot of difference, but if I go and change, for example, something in the code, so in this case, yeah, let me run it again now with after I made a small change. Let's hope that change will catch. It will basically show you a difference between what was deployed and what you have right now in the stack before you do the deployment. I found it a very interesting feature to kind of make for me to make a sanity test to make sure I know what's being deployed or not. All right, so it will show me exactly that my stack, the Lambda function stack name was changed. And I'm going to go with a little bit of a leap of faith and deploy it. And we'll do other things while it's being deployed. Now it's running some unit tests, which I'll show in a minute. Let's hope I didn't break anything in the meantime. All right, all tests passed. The test makes sure that what I think I'm doing with authorization is actually happening. All right, and now it's going to start deploying. Okay. By the way, while it's deploying, when you look at the repo and you want to see how those I wrote, yeah, oh, CDK is it's not something I wrote. This example, yes. Yeah, I wrote it, yeah. Oh, yeah, that's something I can optimize, like the TSC to make a differential. Yeah, yeah, good question. Yeah, I'll be ready after for more deep dive on that. So, a little bit about how I created those custom resources while it's deploying. So I created an interface, an abstract class that you can extend to create other custom resources. You just need to implement onCreate, onUpdate, and onDelete. And for example, I can show the custom domain. So this is my Lambda. I just implement onCreate and onDelete. And I'm just using regular API calls to create, delete, and update the resource. And then I can use that with CDK for any things that is not yet in CloudFormation. All right, so this got deployed, and it will also, part of the deployment, it will generate a static file for me that I can use in my front end to connect to the right resources. And I also made some instructions of what I need to do in Okta. For example, I'll add other IDPs at the end when needed. It will tell me what to put in Okta in order to make that connect. Okay? All right, we still have some time, so I want to show a little bit how is that, after I deployed it, how does it look in the console? So if you're, thanks for staying with me for that part of the code, for those of you who are not developers. I'm going to show a little bit how it looks like in the console. All right? So the first thing that is created in the console is that authorizer. It's very basic. It connects to between my user pool. And I just need to define what's the name of the header that I pass this through. And that header name usually is authorization. Then how am I using this? So this is what the CDK just created. This is the deployment that was created right now. If I go into the method request, I can see that that the authorizer is present there. Okay. And then let me maximize it. Okay. All right. As you can see in that slide, when I show those different types of authorizations, you can do policy-based, you can do interceptor-based, and do it in code. When you do the Cognito authorizer, it's not doing anything beyond validating that your token is valid and that the user has that scope in their access token. Okay? In this case, I just used one of the built-in scopes that they have that they get. It's called OpenID. But there are other options. One of them is using IAM for authorization, which we're not using right here, but it can be very nice for API to API access. Then in Cognito, in the user pool setting, this is where I do the mapping. Those are attributes that are in Okta, and I can, if we'll have time, I'll show how it's set up in Okta. This is the important part. The Okta attribute called groups is being mapped into a custom attribute called groups, and then that Lambda will take it from the custom attribute into an array of groups into the groups claim. Okay? And again, the importance here is that the groups claim will be accessible in both the ID token and the access token. And since there is some preference to use an access token when you make API calls, you don't want to pass all the user information, just the minimal needed. So that's why I like that. This is why I do that mapping. This mapping is optional to do that Lambda mapping. But again, that's the reason, to use a group versus just use a claim. Just use a custom attribute because it will not get into the access token. It will only show in the ID token. And then this is where the triggers are defined. There are a lot of other triggers, okay? And this is the secret sauce, I would say, for this technique. This Lambda. So this is where the association we did in CDK. This is where it ends up. Very straightforward. One thing I wanted to talk about the app client. Okay. As you can see, I can choose which IDPs I'm going to show on that login page for that app client. And one word of caution. You see this is a scope that I could check. It's unchecked by default. And the CDK does not provide it, but I want to make sure it's you know what it does. So this scope allows users to use their access token to interact with Cognito directly. Now, since I'm coming from an external IDP, and I consider that external IDP as the source of truth, I don't want to let users directly do anything to their profile. So it's important, one takeaway from this is to make sure that this scope is not provided to users at all. It's not provided by default, it's not in the repo, but I just wanted to note it out. You don't accidentally check that in. If you do, then it will allow users to modify their profile. And since we rely on those attributes to be mapped from the IDP, we don't make sure that users have no way of modifying them. All right. That is that was also created through a custom resource construct from the code. And we do have a little bit of time. I can show you how settings were done in Okta. Is that something you're interested? Okay.
Where's the GitHub? Where's the
Oh, the link? Okay, so if for those of you who have to go right now, I know lunch is waiting. So this is the link. It's going to be in the presentation. Let me make it bigger. All right. So if you have recommendations, you have comments, you want to make sure that you have questions about it from the talk, submit an issue. I'm monitoring this, and even if you have a very simple question based on the talk, you can use this to ask questions. You see a problem, you find a bug, submit an issue or a PR request. It's very welcome. The talks will be available, as far as I know, both the slides and the video will be available on YouTube. Yeah. So one more thing before we go. If you look at the repo, there is an explanation of what's everything, if you don't remember from the talk, what's in every folder, what's in every module, what's the purpose of every one of those things. And also an explanation of, okay, now we want to just try it and play with it, and you don't want to write a lot of code, you don't want to dive into that code. So even if you're not a developer, you can fork the repo. All you need to do is put some very basic configuration in that env.sh, okay, simulating something that may come from a CI/CD pipeline in the future. For example, the account and the region, I'm putting it as a precaution, so you don't just use the one configured in your command line. So you explicitly say which account you want and which region. And you set up step 4 and 5. You only need to do once to install CDK. And again, it's in developer preview, but I'm using it for a while, and so far I'm pretty happy with it. Step number 5 will deploy a stack that will make it easier to handle assets. So you don't have to manually upload things to S3 to make it, for example, Lambda code and all that. It will make it more seamless. It will zip it for you, upload it for you for a temporary bucket that is not accessible to the world and all that. So that step number 5 is also an intermediate step to do. But then after you did that, every time you want to make changes, you just hit deploy. In the real world, you'll put that as part of a CI/CD pipeline. It will take the information from environment variables. And then quickly, we'll have a few minutes. I'll go into the Okta settings. Okay. So first, this is the assignment I have. I have those users are allowed to access this application. And if we look at let's look at the SAML settings. So there's a little bit of a chicken and egg setup, because Okta will ask you to provide. I have a link in the README of what you need to put here, and it's also being displayed when you do deploy. So the method is to create that. You can put something temporary here as a placeholder, create it, and then it will give you a metadata URL. You just need that metadata URL in order to make all the other things work. You deploy it, and then you go back and update those settings to the correct ones. Okay, the metadata URL, from what I found, is the same between different applications. It's going to be the same whether you had those. It's not affected by those settings. That's what I meant. And this is where I do the mapping from the Okta attributes into what I want to be part of the SAML response. Okay, so similar mapping. I map the first name, last name, and email, and that's the important part, I guess. And again, other IDPs have other ways to do that. In Okta, the way I like it is to have a prefix and say, based on that prefix, every group that is starting with my app name belongs to my app. That's kind of a namespace. And then if the user has any group that starts with that, it will be added to the SAML response. I don't want to send all of the groups they're part of, just a subset. And yeah, and so basically it's a mapping from the group into the Cognito profile, and then we map that into to Cognito group. And I think that's about it. So let me just go back quick. All right. So we talked about the repository structure, but you'll have that in the slide. This is the link for the GitHub again. And those are the main modules in there. Just to recap, that's the way we're doing this mapping. Okay, that's the structure. It looks a little bit complex, but it's documented. The link for the documentation for how this needs to look like is there, and also added the type information for TypeScript, so you don't have to memorize that. You just you're going to have auto completion for almost everything we created here. This is how you can use this authorization middleware you specify which groups are the minimal groups that the user will need in order to do anything useful. And that's an example of how you make authorization decision in code in a simple way. And that's how you can do that in the front end. Just a recap of the interesting parts. There are some other resources that we discussed here. AWS CDK, AWS Amplify, AWS Serverless Express that can take an existing Express app, just throw it in Lambda. I found it very useful. And this is about how do you add different identity providers other than Okta. There are some other, so if you like the concept of that, so this was used to build the jam sessions. And you can still make it to the security jam, the jam lounge, and capture the flag. It's part of what triggered this talk, to share our experience building those things. So you can play with them hands-on. And with that, thank you. Feel free to reach out, and you can feel free to send me an email. Thank you so much. And please complete the session survey in the mobile app. Thank you.